Hello friends, myself Professor Amit Sagar, and in this video tutorial we are going to learn practical related with the subject embedded and real-time operating system. Okay, so in this video we are going to learn the practical based on program to generate PWM signal using Cortex microcontroller development board. Okay, so let us start with the aim of the experiment. So what is the aim of experiment? So our aim of experiment is to program, we have to write a program to generate PWM signal to control the DC motor using Cortex microcontroller. So what is the hardware required for this particular experiment is we need Cortex M3, that is LPC 1768 development board, FRC connector we require, then power supply with adapter. To perform this practical we require some software, that is Kill Microvision 4 and Flash Magic. Okay, so Flash Magic is required to burn the hex file on the development board. Okay, so let us begin with the some concept related with the pulse width modulation in the Cortex microcontroller. So here I will show you a diagram in which you can understand how we can generate the pulse width modulated code in the Cortex microcontroller. Now this is actually a diagram. It shows the how the PWM module works in case of your Cortex microcontroller. Here the main register in this particular is the TC register, that is the timer count register. Okay, and there are two more registers are required for PWM operation. Okay, the two important register is match register, okay, and match register 1, MR0, okay, and MR1. These MR0 and MR1 are pulse width modulation registers in which the MR0 is required for cycle time value. Okay, so what frequency of pulse width modulation is required, that value we have to load in the MR0. Again, the MR1 register is required for duty cycle value, whether we need 10% duty cycle, 20% duty cycle. Okay, so according to that we have to load the value in the timer, that is MR1 register. Okay, now we will briefly understand this particular how the PWM module is going to work. Again, to increase the delay or to increase the time, what we can say, to increase or decrease the frequency, we can make use of this prescaler divider block. Okay, so first of all we will understand this is actually the timer is used for performing the PWM generation. Okay, so TC is nothing but the count register. Okay, so whenever we start the PWM module, okay, now before starting the PWM module two values are loaded, that is a cycle time, or which is nothing but the total that is frequency time. Okay, so for example if we load the 100 value here, okay, and here we load 60 value. Okay, now every time for every clock pulse the time count register is going to be incremented by 1. Okay, and this timer register value is compared with MR1 as well as with the MR0. okay, with the help of comparators. Okay, so with the help of shadow register, the shadow register temporarily keep the value of MR1, and here also the shadow register temporarily keep the value of MR0. Okay, so for every clock pulse the timer count register will be incremented by 1, and it is compared with the duty cycle and cycle time. Okay, so first of all, when we start the timer module, okay, so output of your this particular pin, PWM pin, will be raised high. The output pin of PWM will be raised high. Okay, now initially if the count we suppose as a 0, for every clock pulse the count value or the TC register will be incremented by 1. Okay, now as soon as the value of this TC will become 60, okay, so TC has become 60. Okay, now this particular comparator, the upper comparator is going to reset the particular pin, and the particular pin will be made low. The particular pin will be made low. Okay, now we will understand the task of the upper comparator is to keep the particular pin low if the TC register count and MR1 count will be same. If MR1 and TC register count is same, then this upper comparator will reset the particular pin. Reset means it is going to make the particular pin low. Okay, now opposite of that, now again the terminal count register is still incrementing the count. Okay, now this TC register is again incrementing, and when it is going to reach the value 100, okay, that means the TC register count value and MR0, if these two register value is same, then the particular pin will be made high. Okay, and from the count 60 to count 100, the pin is kept low, and again the pin is triggered high by the particular comparator. Okay, and in this way, with the help of this MR1 and MR0, we can generate the PWM waveform. Okay, the only thing is that the frequency of the particular cycle or the waveform, okay, that will be decided by MR0, and the duty cycle is decided by the MR1. So duty cycle means what? The on time. If you reduce this value of the on time, then this also will be get reduced. Okay, so by changing the value of duty cycle register, that is MR1, you can change the PWM waveform width. Okay, so this is how we can generate the pulse width modulated waveform. Okay, and with the help of this pulse width modulated waveform, we can increase or decrease the speed of the DC motor. Okay, so let us understand how the interfacing can be done with the LPC1768 controller. So this is actually the interfacing diagram in which we are having the LPC1768, that is Cortex controller. To drive the motor, we have the this particular transistor driver circuit. Okay, and the diode is for the protection for motor. Okay, whatever the back EMF will be generated, that back EMF will be nullified with the help of this diode D1. Okay, so this is interfacing diagram. Now let us start with the actual practical for this particular experiment. Okay, now to perform this experiment we need the code for this particular. So here we have the code for this. Okay, so here I copy the code. Now related to this particular, we need a software called Kill Microvision 4. So I am opening the Kill Microvision 4 software. Okay, now we will carry out the different steps required for performing this practical. So first of all, click on project, new project. Okay, so on desktop I will create a new folder called PWM. Okay, I create the PWM1. Okay, so here I have created the folder PWM1. Under this I am creating the project PWM underscore DC. Okay, so click on save. Okay, so here you have to give the controller name LPC1768. Okay, so under NXP you will find this LPC1768. Click on OK. Now it will ask copy startup code, then click on yes. Okay, so you will see in the project window target 1 folder is there, again source group 1, this startup.s file is added. Okay, now click on this new file. So here I have typed the code. Instead of typing I have directly taken the code. Okay, so you have to type the code in the editor. Now while saving this particular code you have to take care that here I am naming the particular file pwm.dc, or simply I will write pwm.c. Okay, so here I am naming this particular code file with the extension. Here you must have to give the extension .c. Click on save. Okay, but still this file is not added under this particular. So right click on source group 1, add this file. Okay, so in the same folder you will find this particular file pwm. Click on add, then close this file. Okay, now one more thing is we require certain files to be added in this particular project. Okay, so what are those files? Already I have kept on my desktop Cortex files. So you have to add core underscore cm3 LPC1768 includes, then system underscore LPC17xx. So these 3 files we must have to add into the project. Okay, then only I can be able to build the code or build the hex file. So now I'm going to include these files. Okay, so for convenience I have kept all this file on the desktop folder. Okay, add this file, right click on source group 1. Okay, add existing files. Okay, now seek for the desktop. Okay, so Cortex files. Okay, now here you can see only 2 files, so click on all files. Yes, now I can see 3 files here. So select all files, add, then close. Okay, now some setting is required. Okay, so right click on target 1, option for target 1, click on output tab, click on create hex file. Okay, then after that one more very important step you require is, okay, you click on C++ tab. Here you have to give the include path. So click on this include path. Okay, so new. Okay, click on this one. again click on this. Okay, so now I have to give the folder Cortex files. Okay, so where the three files, we have added the three files in the project. Okay, so the same folder we have to give as a include path. If you don't give this path, then it is going to show you the error. Okay, so we have done the setting, that is in the output tab create hex file, in C++ tab we have to give the include path. Click on OK. Now if you want to check whether you have written correct code or not, so now click on build. Okay, so now here you can see in the output window 0 error and 1 warning. Okay, so warning can be neglected, it can be some sort of simple kind of warning may be there, or you can simply rebuild the code and check again. Sometimes there can be a minor warning. Okay, still that code can be executed. So in the output window you can see, okay, 0 error and 1 warning. So if there is a 0 error, we can burn the code on the particular kit. Okay, so this is how we can build the project for Cortex microcontroller. Okay, now let us begin with the understanding of the code. Okay, so first of all, the header file is included lpc1768 underscore includes.h. Then the code for the delay is given here. Okay, then after that main function. Okay, always remember that the starting point of execution of any program will be main function. Okay, so you have to take care while writing the main function. So here we have declared one integer variable period, that is of 9000. Okay, then one more variable we have declared I for looping purpose. Okay, then after that the PWM1 pin number 5 we have to configure as a port 1 pin number 24 we have to configure as a PWM. For that purpose you have to program the pin select register. Okay, so pin select register is very important. If you do not make proper configuration of this pin select register, you will not get the outcome of the experiment, even though if you write correct code. Okay, so we know that in Cortex controller for every single pin there are multiple functions. Okay, so therefore you have to select a certain function of the pin using the pin select register. Then we have to enable the PWM peripheral using pcon register. Okay, the bit number 6 in the pcon will if you set the particular bit, then PWM peripheral will be enabled. Then the TCR register initially set to 0. The PR register is set to 0. The prescaler, we are not using the prescaler, that's why it is kept 0 value. Then configuration register, MCR, match control register. Okay, so match control register is for configuring the match control event, whether we want on match what event we have to trigger. Okay, if the match is occurred, whether we want to trigger the pin high or to trigger the pin low, that configuration is done using the MCR register. Okay, then after that match register 0 is loaded the value -1. Okay, period -1. Okay, that is to MR0 is to set the frequency value. The frequency value is loaded. Okay. Then PCR register is to select the age. Okay. The PCR PWM1. Okay. PCR register, peripheral configuration register. Okay. So which mode we have to select. Okay. And then after that the TCR is enabled. Okay. The PWM module will be enabled and the timer is going to start. Okay. Now this is just an initial condition. Once this particular instruction is given, the PWM is going to be started. Okay. Then the match register MR5 is having a duty cycle value. Okay. So whatever the duty cycle value we have to load, that we are going to load in the MR5 register. Okay. And when you change the duty cycle register value, the LER latch enable register is also we have to configure. Okay. So here what they have done is the duty cycle value is changed, okay, every time with the delay of 1 second. For every 1 second we are changing the delay value. Okay. And this is how we are changing the speed of your DC motor with the every what we can say the every 1 second. Okay. Now if you want to see the simulation of this particular, we have to click on the build. Okay. So once you give the build command, yes, you can see 0 error and 0 warning, right? Now click on debug. Okay. Okay. So click on OK. Now this is actually the pulse width modulation. So we can see the pulse width modulation module. Okay, PWM1. So once we run the particular module, you can able to see the different readings will be there. So here I click on run. Okay. So when I click on run, the timer count is going to be incremented. Okay. And now if I want to observe the particular pin, okay, port 1 pin number 24. Okay. So I will observe this particular pin. So I will try to observe this particular pin. Yes, not logic analyzer. Yes. Okay. So here I have to give some setup. Port 1.24. So friends, what we need is you have to open the logic analyzer, then you have to click on setup. Okay, so here click on setup. Okay, so here you have to write add port 1.24. Okay, so already I have taken this. Okay, so when you write this particular setting, okay, I once again show here. Okay, so port 1.24. okay, then click on close. Okay, Now I am not able to see any of the waveform. Okay, so click on all. Here I click on all. Okay, then you have to click zoom in and zoom out. Okay, so once again I have to configure this one. Okay, so I once again show you this. Click on setup, then port 1.24. okay, so this is going to happen here. Okay, sorry. So here click on this one, and here you have to click on bit. Okay, and then click on close. Now click on all. Okay, so now make it zoom in. Okay, all right. So this is how we see the required waveform on this logic analyzer. Okay, so I hope all of you have understood how we can generate the pulse width modulated waveform, and how we can see the output in the simulation, that is a logic analyzer. Okay, so here I click close this one. Now in this pulse width modulator you can see the timer count value will be incremented. Okay, so match register MR0 is also given a value. You can see the value of MR0. Okay, and there will be one more value is there, MR5. Okay, so whenever MR0 match is occurred, the reset is going to be done. So that's why here reset on MR0 you can see here. Okay, so I hope all of you have understood the practical, and you might have understood the step how we can perform the practical, how we can perform the coding and perform the simulation with the help of Keel Microvision software. Okay, so if you have any sort of queries, you can mail me at shirsagar.an, or you can call me at 9527 299 300. Okay, so thank you very much for your patient listening.